Hey everyone, we're going to talk today about logs in the Desmos graphing project. We talked about exponentials in the section before. Logs are going to go kind of the same way. So I have a log equation right here that I'm going to model. And right now we have kind of this a natural log of d times x minus h. Notice the d is outside the x minus h, but inside the log, and then that plus k on the outside. So that's the equation I'm going to use to do a log. I'm going to make this a, right, 1 for now, and this d also 1. So this is our kind of usual shape of a log, something like this. Got a vertical asymptote, so it gets really far down toward negative infinity, kind of flat. On this left edge, and then grows very slowly to the right. So kind of the opposite of exponentials. So exponentials and logs are inverses. So exponentials have that horizontal asymptote, x's and y flipped, and the logs will have that vertical asymptote. So we can use that in some places, right, on our graphing project where we maybe have some vertical pieces that then curve and start to grow somewhat slowly to the right or to the left if we change things around. So you can also modify this so it's upside down, right? So this A will kind of make this sharper until we flip around, and then it'll grow. Sometimes you may see it cut off. That's usually just because whatever computer you're using ran out of computational space, and then things started rounding off to negatives that won't evaluate inside that log. So if it gets too sharp, right, then you may see that graph kind of cut off at that point. But really that vertical asymptote is still there. It does go down to negative infinity, just the computers aren't able to show it. So do keep that in mind as you're trying some of these guys out. So let's go and find a place on this graph where we could do a log. And what you're looking for a lot of times is sort of these places where you're vertical and then you grow to the right kind of slowly, or sometimes not so slowly, right? You can modify with this D how if it goes left or right. So it may grow to the left, may grow to the right with those guys. As that A increases, right, can stretch it out where maybe it's a more gentle curve and not quite as sharp a curve. So let's go and try to identify somewhere on here where we want to do a log. So one place I see where, particularly with the shading, is right here in between this, on the head between this orange and cream color. We might could do a log like somewhere in there. So it does get a little bit vertical, and we are gonna start to grow kind of slow over toward that right side. So I'm gonna modify this A so it's a little sharper. That means I'll probably have to move things around as I'm doing that. And then we can also adjust, right? Maybe that D, maybe move that up a bit. All right, so somewhere maybe in there, it's looking somewhat good. And again, this right doesn't have to be super exact, but we do want to be kind of close. So I may not go all the way down to here. I may cut it off at some point in that vicinity and just see. And I may end up using in the future maybe something else rather than just this guy. So I think this is looking somewhat okay. I want to move that over just a bit and maybe try to get that to go up a little bit more. So I think something along those lines looks pretty good to me. Again, we're going to cut it off kind of where the hair is up here, and then probably where like this first little whisker line starts down here. So it looks like that x is around negative 2.52, somewhere around there. And then it says undefined after that. So we'll see how good this can get. I may have to adjust these values a little bit. Um, so I'm going to go ahead and put in, let's put in this. So y equals that a 0.5 times natural log d times x minus h, and the h is negative 2.52, so I'll put in plus 2.52, and then plus k, which is 11.07, so plus 11.07. All right, so there's that curve. We are going to restrict it now. So we said this is going from that negative 2.52 less than or equal to x, right? And that includes the whole line. I don't really want that whole line, so I may have to go a little bit more to the right. So maybe we'll say 1.9, right, instead. That's maybe a little bit too much. So you can, right, always kind of guess and check some values here. I think a negative 2.518, we just weren't able to get that with the sliders necessarily on there. But that's looking about the place that I want to stop. And then we'll stop over here on the right at around this negative 1.5. Right, so we'll say that also less than or equal to negative 1.5. All right. And that looks pretty good. So that's about where that spike is going to take off, and then I'll probably just use a line for that spike from there. So that would be an equation, right, that we want to name. So I might call that like come up with some name, but I would need to use a subscript like left, right, face, edge, or something like that. Just something that will describe to me where that is, or some name that I can use in the future when I'm doing the shading. So I'll go and leave it like that for now. I may change that in the future if I decide I need something else, but we'll leave it like that. I'll go ahead and change the color. And this I can use, right, maybe either that orange color or the cream color. So I have this one called fur, right? That one's the skin, that's for Calvin. But I might use that fur, that would be that yellow color, or I could use the orange that's right there. So either one of those will probably mostly just be used for the shading. I think I'll go with the fur color right there, and then we'll call that good for today. So and then again, we'll say done on that. So that is the edge that I would use. I'd probably go over this part again in black and just redefine my curve as from here to this new stopping point a little bit higher up with black as well. So sometimes you may have to go over a few different places more than once, just because you might need more of this part for the shading and then less of it for the actual line that you're going to have that's in a different color. So Desmos doesn't do lines as one color, fill as another color. It's kind of all the same color. So I will need to go back and put in a black line after that as well. But that'll do it for today's video, and we'll catch you on the next one.